In this lecture, I'm going to explain doubly linked list. How this structure is, again, it is a collection of nodes, but we have one more pointers. Okay, so the middle one is my data. So this is my data. So this one is a previous node address. This field is a next node address. Okay, take assumption this is 100, 200, and 300. The node, this one is 5, 7, and 2. Okay, so this is my first node. So head is pointed here. So and this value is 200. Okay, because the next node is 200, so a pointer is pointed to here. And this is a previous node, right? The previous node of 7 is 5, right? The address of 5 is 100. So you can point 100 here. So automatically it will be pointed to this node. Again, this place I have to make it as 300. So this pointer is pointed to the next node. This place, the previous node is 200. So automatically this points to this node. Okay. What about the first node? Okay, there is no node is there before this, right? So I can give it as a null value. Here is also there is no next node is there if you reach a last, right? So this is like I can give it as a null value. That's it. So this is my doubly linked list structure. So how can I create a structure for this one is so I can, if you clear the linked list, it's very simple, right? Easily we can do that. So structure name followed by the first field is a previous node address, right? The last field is also next node address. Okay, how we can do the next node address? Self-referential structure. Same thing I'm going to use here, and here is a self-referential structures. Here is a data, it's my integer value. So I'm going to give it as struct node. The name of the first field is I'm going to give a previous node address. Middle field is I'm going to give it as an integer value, say int data. Third is again self-referential structure. So struct node star next. This is a next node address. That's it. My structure is over. Using this syntax, I can create like this. Okay. First, here is also the same 5 kind of operation we are having. One is create, another one is insert, next one is delete, third, fourth one is a search, fifth one is display. These two is same as the previous one. You can take it the previous lecture. The search is common, right? You are going to search the element. I can go with the next position where it is available that I can print. Display is also only the element you have to print on the screen. Okay, the first 3 alone I'll tell you. First in this lecture, we'll move on to the create function. I want to create a single node like this. Okay. Assumption of this node address is 100. Okay. Previous node is no node is there. So here I have to make it as null. Here is also how to maintain as null. So I'll start with the first new node. So struct node some temporary point. So temp. This node name is now temp. Space also I can give. So temp is equal to, we know the syntax, right? Malloc size of struct node that you can give. So after that, you have to fill 3 places, right? Temp of previous, How can I access this field? Temp of previous. This is temp of data. This is temp of next. So next field is, we can give it as temp of data. Last field is temp of next. Two places you have to maintain null value, right? So previous is equal to null. Next is equal to null. This alone you can give it as 5. Okay, finally you have to point the head node here, right? So you can give it as head is equal to 10. That's it. This is called as creation. Thank you. We'll see in the next lecture insertion and deletion.